G'day, in this video we are beginning to look at momentum. So this will start off a new inquiry question, which is inquiry question 3, which is all about how the motion of objects in a simple system is dependent on the interaction between objects. Really, that's just asking about the idea a lot of the time of collisions and how objects can interact when they collide. Now, dot point 2 ask us to analyze and predict the results of interactions in elastic collisions. And here we focus on the conservation of momentum and kinetic energy. Now, already we have identified and explored kinetic energy in a little bit of detail. It's going to be quite difficult to apply the law of conservation of momentum without understanding momentum fully. And that's what this video is all about. Here, we're just going to look at defining momentum and then just applying a simple momentum formula to a real world scenario. So first off, our momentum formula, it's actually quite hidden in the data sheet itself. The equation that's been highlighted is actually related to the conservation of momentum a little bit more directly. However, what is being written here really just does stand for momentum, and that is that momentum little p, not big P like power, is equal to mv. So it is a vector quantity, as I have identified in the equation. And essentially, you can sort of define momentum as mass in motion. Momentum essentially is a measure of how big an object is and how fast it's going. In other words, if you have an object that is moving with large mass, this will increase momentum. And if you have an object with a high velocity, it also will have a high momentum. So there are two ways that we can show units of measurement. The first one is kilogram meters per second, which is very much linked to what's being shown here in this equation, this idea of mass, kilos, times velocity, meters per second. The other one here is Newton seconds, and it actually has something to do with this equation here, which I'm not explicitly identifying today. It's very much connected to momentum. In fact, you can see there it says delta P, so the change in momentum. It's something that we're going to focus on in much more detail explicitly in the following video. But here, force, newtons, times, time, seconds, Newton seconds seems like a reasonable way of showing momentum in units of measurement as well. So a simple momentum calculation for today, we have a 12-ton bus accelerating from 80 kilometers an hour to 107 kilometers an hour. We're being asked to calculate the change in momentum of the bus. So some information that we have in this question is that M is 12 tons, so that's 12,000 kilos, big bus. U, the initial velocity, is 80 kilometers an hour. But if we were to convert that to meters per second by dividing by 3.6, that should give us 22.2 meters per second. And V, the final velocity, is 107 kilometers an hour, which when converted is 29.7 meters per second. Now the question itself, what it is asking for is for delta P. Now reflecting on delta P, and what that might actually mean, that's a change in P, a change in momentum. And whenever we calculate for a change, we take the final result and subtract it by the initial result. So our final result here, our initial result here. In other words, what's the momentum of the bus at the end when it's going 107 kilometers an hour? What was the momentum at the beginning when it was 80 kilometers an hour? And essentially just subtract both of those momenta from each other. So that might look like PF minus Pi. And another way that we could write that, because that we know P is equal to mass times velocity, is to then get that all in there together. So delta P being the initial momentum, being the final momentum, mv, minus the initial momentum, mu. All we need to do from there is simply substitute and calculate. And that should be equal to 90,000 kilogram meters per second. And there you go, a simple momentum calculation. We even got some change in momentum sort of woven in there, which will actually help us for our next video, which will be about impulse, which is a measurement which is really similar to momentum, very closely related, but we'll talk about that in a little bit more depth in the next one.